This is part two. We'll see supernormal growth cases of stock valuation. Let's look at the example. Suppose a firm is expected to increase dividend by 20% in 1 year and by 15% in 2 years. After the dividends will increase at a rate of 5% per year indefinitely, if the last dividend was $1 and the required return is 20%, what is the price of the stock? Remember, we have to find the present value of all expected future dividends. So first thing we need to do is finding the first timing they start to behave like constant growth model. Let's draw a timeline. Forever, right? So first year, 20% increase. Second year, 15% increase. And then 5% increase forever. So from year 2, we have constant growth rate. Which means that we can divide this problem into 2. So step 1, find price year 2. The timing when start to behave like CD, a constant growth model. Because we have G, 5%, and R, 20%, and then we need D3, which is $1, first year 20% increase, second year 15% increase, and third year 5% increase. So 1 times 1.2 times 1.15 times 1.05. D3 will be 145. I rounded up 2 decimal places. Then we find P2 equals to D3 divided by R minus G. D3 is 145, R is 20%, and G is the 5%. It's going to be $9.67. Okay. Step 2. Now let's assume that we sell this stock after 2 years. First year, we receive dividend $1.20. Second year, 15% increase, right? So it's going to be $1.38. And then we sell it for $9.67. Because the price year 2 is $9.67. So price today will be 1.2 dividend 1 divided by 1 plus 20% all present value plus 1.38 plus 9.67. That's the second year cash flow divided by 1 plus 20% square. So the present value. So some of the present values. You can also use the cash flow worksheet from the calculator using CF0 equals to 0, C01 equals to 1.2, F01 is 1, and C02 is 1.38 plus 9.2. $9.67, I mean. And then F02 equals to 1. Calculate MPV. So press MPV, you have I equals to 20 and compute MPV. You're going to have $8.67 as a price. $8.67. You should have exact same answers if you use calculator. So this is one way. So remember 8.67, okay? $8.67. Now there is another way to solve this problem. Instead of finding the first timing that behave like constant growth models, let's find the first dividends that behave like constant growth model. So very similar. 20% increase, 15% increase, and 5% increase forever. You have D1, D2, D3, no forever, right? What is the first dividend that start to behave like the constant growth model? That's the dividend 2. So instead of finding timing, let's find the dividend itself. And step 1, find the price using this dividend, the first dividend that behave like constant growth model. Find the price in the previous period, P1, right? So P1 equals to D2 divided by R minus G. It is clearly right because the model only require the next dividend will grow at G forever. Doesn't have to be from current dividend. From next dividend, it grow at G forever, at a constant rate forever. So if you find this price, then D2 is 138 as we calculated, divided by R is 20%, G is 5%, you have 9.2. Then step 2, now you have only 1 year cash flow. So you have D1, which is 120, and you sell it 920. So let's sell it next period. Then the price will be 1.2 plus 9.2 divided by 1 plus 20%. So that's the present value of this first year cash flow, which is exactly same answer, 867. It is up to you which way you choose. I personally prefer second way because it reduces one more step, but both should give you exact same answer. Pop quiz 2. Suppose a firm does not pay dividend for the next 3 years and start to pay $1 dividend from year 4. After that, the dividend will grow at 5% forever. With 15% discount rate, what is the value of this stock today? It is very similar, except that a firm does not pay dividend initially and grow at a constant rate forever. Please solve it. If you have some difficulties, please go back to the previous example and fully understand it. To solve this problem, let's find the timing that starts to behave like constant dividend growth model. No dividend for 3 years, and then start to pay dividend 4th year, and then 5% increases. So year 4 is the first timing that start to behave like constant growth model. So we can get P4 using D5 divided by R minus G. And D5 is $1 times 1 plus growth rate 5% divided by R is 15%, G is 5%, so 1050. So let's assume that we sell this stock in year 4. Now we have year 4, D4 equals to $1 and P4 equals to 1050. And there's nothing else. So this is just one-time lump sum cash flow. Simple cash flow. So price today will be D4 $1, P4 the selling price divided by 1 plus 15% to the fourth. If you solve this, then you're gonna get $6.58. You can obviously use calculator too. It's up to you. However, you can also use the second way. Instead of finding the timing, let's find the dividend that start to behave like constant growth model. And that's the first dividend is D4. Using this D4, we can find P3 equals to D4 divided by R minus 3. So it's 1 divided by R is 15, G is 5%, $10. And let's assume that we sell it in year 3 for $10. And there's no dividend. So the only cash flow is the $10 dividend, the selling price in year 3. So price today is $10 divided by 1 plus 15% to the third. Back to the present. You must have same answer again, $6.58. Again, you can choose either way. You can choose either way. Find R. As we saw in the previous slide, R can be rearranged using the dividend growth model. D1 divided by P0 plus G. Using this formula, we can solve this example quite easily. A firm's stocks is selling for $10.50. They just paid a $1 dividend, and the dividends are expected to grow at 5% forever per year. What is the required return? Just use your formula, R equals to D1 divided by P0 plus G. Since we only have D0 though, we can use D0 times 1 plus G divided by P0 plus G, which is 1 times 1 plus 5%, $1 dividend and 5% growth, divided by 1050 current price plus 5% growth rate, then you will have 15% R, the required rate of returns. Among these 15%, 10% is dividend yield, 5% capital gain yield. Another pop quiz. You observe the stock price of $18.75. You expect a dividend growth rate 5%, and the most recent dividend was $1.50. What is the required returns? Just use a formula and solve it. We have to use the formula R equals to, now D0 plus 1 plus G divided by P0 plus G, because we don't have D1, we have D0. So it's going to be 1.5, that's most recent dividend, times 1.5 times 1 plus the growth rate, 5%, divided by the price, 1875, plus growth rate 5% again, then 13.4% is the answer. Final topic is the alternative way to evaluate the stock, especially when dividend information is not available. One of the biggest caveats of the dividend growth model is that we cannot use this formula for the firms that do not pay dividends. These stocks may be evaluated in different ways. We can easily find earnings per share, EPS, from the company's financial statement. Once we get the EPS, we can multiply it by some benchmark PE ratio, usually industry average PE, then we can get the price per share. Since PE ratio is the price per share divided by EPS, that's the PE ratio, and times EPS should be price per share. If trustable PE multiple is not available, then we can use price to sales ratio instead. It's very useful, especially if the firm do not have very low PE ratio or negative PE ratio. We can use price to sales ratio. Example, suppose we are trying to value the company that does not pay dividends. If the appropriate industry PE ratio for this type of company is 20 times, and you predict earnings to be $2.50 per share for the coming year, then the forecasted stock price for a year from now, the target price will be simply 20 times. So PE ratio 20 times, EPS $2.50, $50 will be the target price. So that's another way to evaluate the stock using the multiples. There is some problems when you use multiples. The biggest problem is we cannot trust this financial information, financial statement, since this is from accounting. So there is accounting flexibility. You can increase, decrease earnings by choosing different accounting procedures. It's not illegal at all. It's up to the company that decides these procedures. This is called earnings management. Because of this earnings management, valuation using multiples may have some problem. That's the biggest disadvantage of the valuation using multiples. But the advantage is this is very easy to use, and the information is all available, and there's less estimations, less forecast. All right, this is the end of the chapter 7. For this chapter, I strongly recommend you to find some problems, practice problems for supernormal growth cases, non-constant growth cases. In the textbook, you can find several problems. Thank you, and see you in the next chapter, and goodbye.